Hi everyone, it's me, Kritika, Assistant Professor, Department of Chemistry, K.S.Rangasamy, College of Technology. Today we are going to see about the topic fuel cells. So what are fuel cells and what is a hydrogen oxygen fuel cell? Principle, advantages and applications. So first you should know about what is a fuel cell. So it is an electrochemical cell that generates electricity from fuel, that is via redox reactions. What is a redox reaction? That is reduction as well as oxidation takes place. So both reaction takes place in a particular reaction that we called as redox reactions. So fuel cells, or it is an galvanic cell here, in which chemical energy of fuels is directly converted into electrical energy. So that we called as a fuel cells. So it requires continuous input of fuel. Here example is hydrogen and oxidizer is oxygen. So what are the components present in fuel cell? Anode, cathode, electrolyte. See the diagram, you may understand that H2, how the ions get ionized. Then we go next move on to the characteristics of the fuel cells. So it do not store chemical energy. Reactants supply continuously, products removed continuously. So efficiency of this reaction is approximately 2 into the conventional power plants. So there will be a no noise, there will be a no vibration and also no thermal pollution. It was operated under reversible conditions. That is, both reactions can be taken place over here. Then we see about the hydrogen oxygen fuel cell. It was first demonstrated by Francis Thomas Bacon in 1939. Uses porous carbon electrodes with catalysts. What are the catalysts he used is PT is platinum and palladium silver alloy or nickel. These metals are used as an porous electrode, that is the catalytes with the porous carbon electrodes. What is the electrolyte used for this hydrogen oxygen fuel cell is concentrated KOH or NaOH. So this KOH alkali or NaOH alkali is used for concentrated one. Then for low temperature, potassium thiocyanate in liquid ammonia is used as an electrolyte here. And then we see about what is the working principle of the hydrogen oxygen fuel cell. So see here, what is this is an anodic reaction, cathodic reaction, and electrolyte. What is the overall reaction over here? So in anode, what happens? That is H2 is oxidized to form H plus plus electron. So electrons is liberated out. That hydrogen is splitted into H plus and electrons. This electron, see here, the yellow color arrow mark which shows the movement of the electrons from here to here. So what is a cathode? So cathode is, see here, this is a cathode where oxygen plus this water plus the liberated electron was taken over. The liberated electron was taken over this reaction, cathodic reaction, to form OH minus ion. There will be a formation of OH minus ion. So what is the overall reaction is the H plus plus OH minus to form H2O. This is a overall reaction. So the anodic reaction, also called as oxidation reaction, and this cathodic reaction also called as reduction reaction. So this reaction also we can tell as a oxidation half cell reaction and reduction half cell reaction. This shows that it is an overall net reaction, overall fuel cell reaction. Then, so the multiple cells are stacked to form a fuel cell battery. So multiple cell to form this one. Okay. So the EMF of this one we found to be EMF of this reaction, which is equal to 1 volt. Okay, then we see about advantages of this reaction. What are the advantages? High efficiency for this H2O2 fuel cell. It is a portable one and low maintenance cost. no harmful exhaust from this reaction. Water is the byproduct which is useful for drinking purposes. This is the main thing. And then ideal for space missions, no noise or thermal pollution. So there is a no noise in for this reactions and all. There will be a no pollution to this reaction. And then we move on to disadvantages of this reaction. What are the disadvantages? Corrosive electrolytes. That means the electrolyte may be corroded. And then hydrogen storage challenges. How we have to store this hydrogen? No. So this is a challenge one. And then uncertain lifespan, and then high cost of pure hydrogen and catalyst. See, what are the catalysts we are using over is platinum. This is a costly one, no? And then palladium and silver alloy. So this is also silver. This alloy we call this alloy also costly one. Okay, so that this is a high cost pure hydrogen and catalyst are used over here. This is a one of the disadvantages. So what are the applications? Space vehicles. So mostly it is used in space vehicles, submarines, military vehicles, hydrogen powered buses. That is it is used, it is running over there in Chicago, London and Beijing. Hydrogen fuel cell trains also available over there where Germany, Japan, USA. So NASA. So here rocket fuel and onboard power. For this H2O2 fuel cell is used. Stationary fuel cells for cities, buildings and remote areas. Okay, let me see about what are the scope of this future aspects. So it supports low carbon energy transition, zero carbon energy carrier. It enhances energy security, applicable across transport, heat, electricity sectors. So addresses over two-thirds of global CO2 emissions. So for this CO2 emission was decreased due to the replacement of H2O2 fuel cell. Okay. So what is the summary by this reaction is that fuel cells are clean, efficient, versatile. Hydrogen oxygen fuel cell offer promising solutions for sustainable energy. So continued innovation can expand their role in global energy systems. So thank you. This is about the H2O2 fuel cells. Thank you everyone.